Okay, we're ready to start. It seems like a Monday, but it's already Wednesday. Tomorrow's assessment number 8. Wow. They're going too fast. I had to make a road trip, believe it or not, to the middle of North Dakota. I had a relative in the hospital, so all weekend I was driving, and last night coming through Illinois, the rain was incredible on the interstate. Everybody had to slow down. You couldn't even see the white line on the right because it was hanging on the road so long. So if I seem tired and crabby today, yes, I am. Let's see, before we get going, Sarah's going to make an announcement. I guess Sarah or Aaron or both or together.
So we're going to have a review session tonight at 7:30 in room 3102. We'll go over a little bit of the past material, the exam, or the test we just had, and then we'll review the stuff for this test as well. So.
Okay, so if you can get that down, I'll put it on the screen for them. You said 3102, which is the classroom. Oh yeah.
Yeah, it's just right down here.
Okay, right down the hall.
So feel free to come with any questions you have as well, or topics you want to cover. But we'll have a
Okay, 7:30 you said, right?
7:30.
So, are you, how long are you going to be there? Because if somebody can't come at 7:30, they might know, well, I can get there at 8, and maybe I can get a tail end. How long?
We're planning to be there an hour.
Okay. Okay, excellent. Well, as long as I got this document cam up, well, first of all, I know I have a question on a math question, and I'll see, I'm going to do that, but let's see if there's other questions about anything on past weeks or muscle and bone from the reading video. Anything? Okay. I know some people are watching the videos, maybe others aren't, and remember when I make the assessment, some of those videos I can't remember what's on them, right? I mean, too many, 100 videos ago, so I have to watch them again. I write down things, I read the reading, and I was going to go through some of that today to show you how to take some stuff out of the reading. Anyway, so here's another question for you.
What's the difference between osteon
Osteon
and osteoid?
and osteoid. Okay, let me write that down. And I'm not actually sure. Help me spell osteoid. I just like that. Okay, we'll look them up. Okay, now the neat thing is, there's the first thing ever, one lesson right there is osteo is a prefix meaning bone. I know right away that these are connected with bone, right? Okay, and I'll show you how to look those up. And right offhand, I can't remember exactly what the difference is, but we'll ferret that out. So let me do that on the other screen. And here's the other thing, a little preface. Bone is dynamic. That means you can build up bone, you can take bone away, right? And it's subject to forces because when animals are young, their ribs are very circular, very, they make almost a great circle. After aging and a lot of breathing, ribs tend to become flattened. Okay, because of the forces, okay? So then, making sure I got my right screen up here, let's go to my favorite dictionary, which is onelook.com, and we'll type in osteon and see what it comes up with. And there's not a whole lot of things there, but we've got, okay, a central canal containing blood vessels. Oh, okay, yeah, and okay. So it's the central canal and a bone, okay, that contains blood vessels. Because that's the other thing you got to know. Bone is a living tissue. So if you ever do any dissection, I should bring like a cow's femur up. Sometime I've got some bone in my office or another cabinet. But there's actually, a long bone can be like, let's say this long. And if you look carefully, there's a hole in the bone. And I could put a toothpick from the outside to the inside of the bone. And if you look down the inside, you can see the toothpick. And that's where a blood vessel would be. Okay, so bone is very dynamic. And it's got blood vessels. And It's also called a depot tissue. Now this isn't on the screen, but bone is a depot tissue. That's D-E-P-O-T, tissue, 2 words there. Bone is not the only depot tissue, but when you hear the term depot tissue, what does that mean? If something is a depot tissue, the liver is a depot tissue, the bone is a depot tissue.
Things are deposited there,
What's deposited?
like substances.
Some substance, chemical is deposited there that can be retrieved later if needed, okay? So actually muscle is a depot tissue in the extreme, because if you've ever seen a picture of somebody that's starved for like 2 months, what happens to the muscles? They are like, they're all, that person is all skin and bones, and the muscle has been used to keep the person alive. Because if you break down muscle, then that's amino acids for other vital things, right? And then there's water in muscle. So it's a depot tissue as well, okay, for calcium, especially for calcium. And the animal where this gets the most play is dairy cattle. And when we get to lactation, we can talk about this, but if the cow starts milking and she can't mobilize calcium from her bone, there's an immediate problem, because blood calcium drops and they become paralyzed. And it's really, you know, there's a downer cow syndrome when a cow starts milking. We have genetically selected a cow that once she gives birth, the big switch goes on and she starts milking tremendously, and she can't eat enough calcium to make the milk. So it has to come off the bone as well. So anyway, okay. So, and I should make this bigger for those of you that are reading this. A central canal containing blood vessels and, okay, so it's like, especially in compact bone. Okay, now let's go to the osteoid. And then the other thing I want to do is I want to get a picture of bone that probably has all these labeled. Okay, and there's so many dictionaries, and some of my favorite ones are down here under medicine, but, okay. Now an osteoid is uncalcified bone matrix. Okay, so when bone is made, it's not hard right away, so this is going to be the product of osteoblasts. Okay, so osteoblasts are a cell that make bone, and an osteoid hasn't become calcified yet. Okay? But now, and so see, it consists mainly of collagen, and you know collagen is not hard. So now what I want to do is I want to find a picture of bone where some of these things are labeled. Okay, yes. Is this related to this?
Yes.
Okay.
Speaking of osteoblasts, as you just mentioned,
Yeah.
so I understand that they're the cells that fill the bone.
Yep.
And osteocytes are the cells that make up the bone.
Right. Once
So-
once it becomes a bone cell, then you could call it an osteocyte.
Okay, so like,
Osteoblasts will make osteocytes.
um,
Yeah. And you know what? I wish we could just wipe all that terminology and make it better, because it is confusing. Because in my mind, osteoblast, blast is like tearing down something. I wish it, you know, would have another name. But osteoblasts make bone. And of course, you could click on this. But look at all these osteos, cells that arrive, okay, and they mature, they become associated with production of bone. So let me do a Google, and I want to get a picture, okay? So this is all good because it's all about tomorrow. Okay. Bone structure, bone, okay, no, I want to go osteocytes. Okay. And I want to get some. Okay. Now there's a better picture right there. Look at, there's the osteon is like a unit of the bone. And then an osteocyte is a specific bone cell. So that one's not too bad, but I know we can find better. This one I've seen before, yeah. And this one's probably the best. Okay, so here's a review of bone. Notice there's nerves, blood, artery, vein, lymph. So don't let that surprise you, that all those things are interacting with blood. And then you've got the osteoblast, osteocyte, and then what does the osteoclast do? It breaks it down, yeah. So Osteoblast builds up, and then when the cow, let's say, needs calcium, the osteoclasts tend to be working and mobilize calcium right down the bone, and very important for dairy cattle or any lactating animal, especially ones that stress. Okay, did we do the osteo whatever, those things? Audrey, do you think? Oh, you had the math question, that's right. So are we all set on that? That's a great picture right there. Was that on the video, by the way?
Yeah.
I was gonna say that looks familiar and I really like it, so I probably did steal it, yeah. Okay, very dynamic tissue. Okay, so let's do a little math, because that was one question I was given, and I'm gonna go to the document cam, and let's say, we'll do both ways. We know there's an animal, let's say there's an 800-pound heifer, and we wanna know how much blood she has. There's just a little bit of a logic here. And I love that the student that taught me that, draw a line. I don't do those individual X's that I was trained to do. So I had to work it out. So 800 pounds per heifer. Draw a line. And then let's say we want to find out how much blood she has. I haven't said what units yet. But if I know I've given the whole big animal and I want to find blood, that's got to be the 7/100. Okay? And if you take another class, they might use a different number there, right? 7% is my grand average. I think in the past I've used like 6.5 or 7.5, but then for mental math that gets a little tricky too. So I've gone to 7 now for the last few years. But remember, that's just a grand average. Even horses differ. Draft horses have a different percent than, like, say, hot blood horses, okay, for figuring out blood. So now let's say I want to find out how many gallons. Because that, you know, I've got pounds right now, right? If you did that, that would be pounds. So let's say gallons. I know 1 gallon per 8.3 pounds. So you should remember that. A gallon is a little over 8 pounds. Because remember, there's 8 pints in a gallon, and the mnemonic devices, a pint a pound the world around. It's very approximate. You're off by 0.3 pounds there. Now, if I wanted to do quarts, I could do 4 quarts per 1 gallon. And, I mean, so these are all kind of constants, conventions. Let's do liters. How many liters? I can even go to liters from here because I know there, I'm going to jump fast here, liters. I know there's 3.8 liters per 4 quarts. I could do that. Okay, a liter is just a tiny bit bigger than a quart. So you could go on, right? So these are all constants, but they could be flipped the other way too, given the math problem. So you could work that out someplace else. Now let's say I collect, and then last week there was, like I said, 20 gallons in a horse, right? I saw a horse this summer that big. He was right on that weight. That's kind of why I had that. 20 gallons of blood per horse. Now I want to know, let's say we'll go back up to body weight. So no, I saw a horse this big. Can't remember. It came out to 2,300 some pounds, if I remember right on the assessment. Can you imagine 20 gallons? This guy could donate 1 or 2 gallons and not even cough, right? So it's amazing. But now I know if I start with the small and I want to get to the big horse, I have to flip this thing over to 100/7. And now essentially that would give me gallons of body, but then it's nice to say, if I wanted to go to pounds, 8.3 pounds per 1 gallon. See how on the top it was flipped the other way? So the first calculation gives you basically how many gallons of body, but then we want to get to 8.3 pounds per 1 gallon. And then you could go on from that, right? So many pints. So let's say we want to do pints. you go 1 gallon per 8 pints. But on the assessment, I try to keep it, not too many factors, because then with the mental math or a little in the margin, I don't want to get too far away. But the principle, if you know the principle, you can get those. Okay, other questions? Yeah.
Okay, so there were kind of two different sources about the same information. So in
Are we going to another subject?
body weight of
Oh, body weight.
skeletal muscle.
Okay, body weight of skeletal muscle.
So in
Okay.
the videos it said 40%, but then on the quiz the correct answer was 55%, but there was also a 35% option,
Mhm.
which I figured was closer to the 40. So what are you looking
Right.
for here?
Okay, so let me try to find that. So where was the first figure at?
The 40% was in the video.
The video, okay. So 40% of the video, and where was the other source?
On the quiz it was 55%.
Okay, 40%. And it was how much of the body is muscle?
The body weight of skeletal muscle. Like
Oh,
skeletal
skeletal.
muscle makes up this much body
Right.
weight.
Okay, skeletal muscle, okay. So, body weight, skeletal muscle. Okay, so here's the thing about it. The skeletal muscle is a major part of the body, right? And I think anybody here in meat science, if you have a steer, it's 1,000 pounds, how much lean do you get? Anybody taking that like meat science class and give me a rough estimate? Is it like, don't they usually use 50% or something like that? I can't remember. Yeah, tell me, so it's 62?
62, the average.
So 62, that's probably including like does that include like a steak that you cut and there's bones in there? There's probably some bone in that figure. So dressing percent is a little different because other than skeletal muscle, because then you've got bone and stuff also, so I can see where that's higher. The thing is, skeletal muscle is is a major part of the body, and different sources would be different values. And the thing is, I bet you a horse value is different than a dog, and so you're going to run into these figures. And so, let's say, so what you really want to do is for the assessment. For the assessment, let's say 40%, because sometimes figures do all muscle. And there's 3 kinds of muscle, and that's maybe where the 55% might come in. So it's a convention now. A convention, we're going to say if you want to figure out how much skeletal muscle in any animal, we're going to use the 40% value, okay? Yeah. And then that's why let's get these values set. And so it's in your notes, you can keep me to it, right? So if I somehow wander to the 55%, and maybe if you include all 3 types of muscle and could dissect it out and put it on a scale, it might be 55%, right? You'd have to include heart, but then you would include all the muscles in the intestine. But you can never dissect those out and weigh those. So it's funky. So here's another thing about muscle. I guess I can do the reading, but muscle is an incredible heat source for the body. If you've ever went to the co-rec and worked out, you can, work yourself to a fever. The interesting thing is we're all resting right here. Some of you had breakfast just before class, but a lot of you had breakfast earlier. So you're kind of in a kind of steady metabolic state. What's that called? The state you're in now, most of us. What's that? The state we're in right now, metabolically speaking.
Or in homeostasis?
Well, we're in homeostasis, but there's a term that means we're kind of at a resting.
Rest and digest.
Well, that's the nervous system, but if you had to say where we're at now, it's called basal metabolic rate. If you could harness how much heat we're making, let's say it's 1 unit per minute. Basal metabolic rate. The reason I said away from breakfast, do you know when you eat, you make more heat? When you eat, the digestive processes generate heat. And so if you're ever hot, you probably shouldn't eat, right? That adds heat. Or like when I lived in North Dakota, I fed my dog late at night. because he lived outside. And if it was gonna be 16 below tonight, I knew JR would be a better survivor if I fed him the last thing at night. And they do that out in Nebraska with the cattle. If they're way out, you've got to have something in that stomach to be digesting. And the rumen is incredible. Okay, so anyway, it makes a lot of heat, and we're resting now. But what I'm going to say, 1 unit per minute we're making heat. It's a bogus number, right? Or what if you were exercising the most? How much heat could you make then per unit time? I just want to show you how dynamic it is. What if you were running around or doing track or doing a marathon? That would be a great example to show you how much heat the muscles make, because that's a byproduct, right, of contraction. 10. You can increase your heat production by a factor of 10 by working all the muscles. That's pretty dynamic, right? Okay, so any other questions on that? Because what I'll do is I was going to go through some of the reading and show you maybe how to pick out a few things for tomorrow, since we have time. Okay, so I'm going to go to the grid work, go down here. I'm going to do muscle 1 briefly. Okay, now hopefully the types of muscle are, you had that in high school biology, but it might be rusty, but cardiac muscle is definitely, only the heart. Smooth muscle is in all the tube structures, and it's basically involuntary. You can't say large intestine contract. It's all kind of involuntary. But then muscles, like I'm moving around, skeletal muscle, that's basically voluntary, but it's kind of a general term, because if you ever do a knee jerk reflex with that little hammer, that's an example of a reflex, and that's not really voluntary. I'm not going to, I do it because of a reflex. Okay, so there's all kinds of muscle. Muscle contraction, make sure you know the difference between a tendon and a ligament. That's a nice little contrast. And this one, muscle contraction requires energy and have numerous mitochondria. That's the kind of the powerhouses of cells. If a muscle has a lot of mitochondria, how can you tell that from a muscle right next to it that doesn't have a lot of mitochondria visually? Let's say in a chicken. There's my stomach, sorry, up here if you heard that. White muscle versus dark. The more mitochondria, the darker. The more it's being used, the more it's needed. And then, look at, only 15% of the energy is used for muscle contraction. And the rest is released as heat. So 85% of the energy units used by a muscle in a contraction is made into heat. So that's physiology right there. Then there's a structure of muscle, and then there's a little mnemonic device about tendons versus ligaments. You should know, here's another contrast, insertion versus origin of a muscle. The origin tends to be connected to a bone that moves the least, and it's inserted by a bone that moves the most of the two bones. Flexion and extension, that's a good little contrast. Basically, there's a term, antagonistic muscles. One does, the other one does the opposite. We've had antagonistic terms before. And so that's pretty darn straightforward, I think. Okay, let's go to another one. 2. Okay, and this is very short. It's kind of almost like a rehash of the last one. It does say a few different things, but not a lot. So that one's kind of a review of the first one. Then this is what I wanted to, myopathies. That term means muscle disorders, muscle diseases. And sometimes disorder is better because it doesn't have to be an infectious agent, right? And so they talk about, I guess in horses, muscle atrophy. If a muscle's not used, it tends to atrophy. And so that's a problem when somebody's inactive or not using a muscle properly. Let's see. So then I want to talk about, I'm just trying to see if this one talks about that horse. I want to talk about Monday morning disease in horses, okay? So this is kind of like a little sidebar I'm adding. Monday morning disease, also called tying up. So what's that mean? Any horse person or anybody know what that is? Monday morning disease, tying up, and there's another name too. We'll find that shortly. Anybody?
It's when, like, the way it was explained to me is that, like, the legs just can't go anymore, and so, like, they're so tired that it's no longer, like, digesting things properly, breaking things down properly.
Within the muscle, you'd say
Within the muscle, yeah.
metabolite. You wouldn't say digesting,
Yeah.
it would be metabolizing.
And it can lead to, like, those things that aren't being broken down into the urine, which is, I think, the word.
Right. Okay, that's close. Now the thing is, you said the muscles are tired, right? You said
Yeah.
something like that. Okay, now that might be incorrect because here's Monday morning disease. And this is how it happened years ago when there weren't many tractors. So they would work horses Monday through Saturday. Sunday, they didn't work horses. So they had a whole day of rest or more. And then Monday morning, they would have this tie-up. So it's not because muscles are tired. You had a whole day of rest Sunday. And then you start working the big horse on Monday, and then it ties up. And what it is, there's a little theory that there's too much glycogen being stored in muscle. So it's kind of a metabolic thing for these horses. And we'll try to look up something. But the one theory, and I think this is the best one, it's like too much glycogen is stored, and then when the horses start working, there's too many products being broken down rapidly, and then it causes this inability to contract muscles. And actually the horse will be out in the field and then literally lock up. And the worst thing you can do is make the horse move. So it's called tying up. It's a metabolic thing. And if you let the horse be there for a while, it'll work its way out of it. But it's very interesting. So now that's one of the myopathies. And it may not even actually on this screen tell you about it, but that was my way of introducing this tying up. Question?
Can horses die from tying up? Because I worked for vet, and we had a lot of Amish clients that had that problem.
Yeah, I think that would be an extreme case. I guess I haven't really heard of a horse dying of tying up. But so the Amish is a great example. They have these big horses. They work them. They rest Sunday, is it? And then Monday morning, boom, and it's a metabolic thing. Too much glycogen is being stored in the muscle, and it wasn't used Sunday because they're standing around. And then Monday morning, you start working them, and then you get this metabolic disorder.
Does it hurt? Is it like a
Oh yeah, it's painful too, yeah, it's painful. Don't move them, and a lot of times they'll, just standing there, they'll work their way out of it, or at the extreme case, that might give it a muscle relaxant and a pain medicine, okay? But the worst thing you do is try to make the horse move.
Okay, I know you said that you were gonna get to this, but the
Yeah.
other name for it?
Yeah, I'm gonna look like that,
Okay,
yeah.
because the thing that was confusing me is, like looking at that, in the notes it says that that can be exercise, like a problem of exercise, or it cannot be. That it
Yeah,
can be.
in my example, it'd be not.
Okay,
Because remember, Monday morning disease, no work Sunday. So they've been working all week, and now the muscles have been depleted basically of like a lot of material, and they're like building it up, and then it's almost like too many things to not digest, but metabolize. I'm using your word. Yeah, see, you're a bad influence.
sorry.
No. Okay, so let's look up that other term. Because it's actually a hard term to say. Okay. This is kind of